G'day guys, I'm just going to go through some examples that you can add for your summary journal for simultaneous equations. And this one specifically for elimination. All right, so I'll be going through 3 or 4 examples of simultaneous equations using elimination. Feel free if you want to add any of these to your summary journal. So the first one, and these are just straight out of the textbook. So I might do the very first question. So x plus y equals 5. And you got 2x minus y equals 4. Okay, if you've been watching those Eddie Wu videos, you don't have to, but he's been labeling his equations. So we've got 2 equations here, equation 1 and equation 2. Okay, the purpose of elimination, guys, is what we're trying to do is eliminate or get rid of one of our letters, one of our variables. Okay, so when you've got your 2 equations, the way we do it via elimination is we want to match up, okay, our coefficients. Okay, so if we look in our first equation, all right, we've got 1x here, okay, and we've got 2 x's. Okay, if we look at the y's, we've got 1y here and a negative 1y, okay? So if we have the purpose of elimination, guys, we're trying to get the same number, okay? It doesn't matter if they're negative or positive, okay? That's fine. So in this case, we've got our 2 equations. We actually have the 1y and the negative 1y already. So to eliminate that y, what we can do is we can add these 2 equations. We can add equation 1 and equation 2. Okay, so we're going to have x plus 2x is going to make 3x. Okay, now when we add the y and the negative y, okay, that's just going to cancel out. Okay, so it's going to be 3x equals, and the 5 plus the 4 is 9. Okay, now this is what you were doing from last week. We're going to solve for one of our variables. Okay, so x equals 3. And then what we do is you can sub this x equals 3 into either equation. Now, it doesn't matter which one you choose, but yeah, choose the one which is easier. So I'm going to sub that 3 into the first equation. Okay, and that's going to help us find y. So we're going to use the x plus y equals 5. So value of x is 3. So 3 plus y equals 5. Okay, and then to get y by itself, minus the 3 from both sides. So y equals 2. Okay, so the answer to our first question is x equals 3, y equals 2. Okay. Next example, I'll choose one a little bit harder. Maybe one from question 3. So 3a I'll do. So we've got 3x plus 5y equals 8. And then x minus 2y equals, where is it? X minus 2y equals negative 1. All right, if you want, guys, if the equation's not set out nicely, it can be handy just to align your x's and your y's, all right, above each other. Okay, it might not be written in that order, but it's nice to do it just so you can see which ones match up. So if you look at this equation, or these 2 equations, guys, we see that none of our coefficients, so the x's, all right, or the y's, they don't match up with each other for both the x's and the y's. So what we've got to do is we've got to try and manipulate one of the equations, okay, so that it's going to be the same as the other. Okay, so what you can do is, again, there's a number of ways you can do this, and you won't be wrong either way, but you want to do it the easiest way. And the way that I'm seeing we can match this up is if this 1x here, if we times it by 3, that's going to be the same as this 3x. Okay, so if we multiply this bottom equation by 3, we're going to get a pair of 3x's. Okay, that's what I'm going to do, but if you wanted, Another way of doing it is if you want to match up the y's, you could times the top equation by 2 and the bottom equation by 5, and then you'd have 10y and the negative 10y. So you can do it that way as well, but recommend doing it, the simplest way so you're not dealing with big numbers. Okay, so what I'm going to do is this equation here, I'm now multiplying by 3, so I'm going to have 3x minus 6y. Remember, if you multiply the equation and multiply the whole thing, so negative 3. Okay, so now what I'm going to look at is I'm going to look at this equation. Let's label it A and this equation B. Okay, we can see now that we have two coefficients the same. We've got the 3x and the 3x. Now with elimination, guys, you can either add and subtract the two equations. Okay, so if we go back to the last example, I added the two equations. Okay, this time if I add the two equations, I'm going to get to 6x. Okay, so this time I'm going to have to actually subtract A and B. Okay, so what I'm going to do is I'm going to take these values, and the easiest way I do it is just go vertically. Okay, don't worry about the -1 there, but the 8 and the -3. So I'm going to do 3x take 3 is just going to be 0x or 0. Okay, then we got 5y minus -6y. Okay, so you're going to have two negatives in there. So 5y minus -6y, it's actually going to make it a positive. So it's 11y. Okay, and then 8 minus -3, that's two negatives again. Okay, so equals 11. Okay, once you get to this part, you guys will smash it. Okay, so y equals 1. Okay, and then you can sub that back into one of the equations. Again, it won't matter. I might choose the first equation. I'll do the second. I'll do the second equation. So I'll do our original second equation over here. So I'm going to sub that 1 for the y into that negative with the -2. So you're going to have x minus, and it's -2 times 1, so it's just -2 equals -1. Okay, and now we're just going to solve for x. So add the 2, x equals 1. Cool, so we've got our two answers when x is 1 and when y is 1. So in that equation, guys, you may have to multiply to get two coefficients the same. All right, let's do another one. Okay, so if you ever want to go back on the video and just look through some of the examples, that's fine as well. Let's do a hard one. I'll just do 4F, just we've got bigger numbers. All right, but the process stays the same. 3y equals 22. You got 3x minus 6y equals -11. All right, so in this equation, of these two equations, guys, we can see that we've got no coefficients that match up. So the x's and the y's, they don't align. For me, what I'm seeing, the easiest way to get two coefficients the same is with the y's. Okay, I can multiply that 3 by 2 to get it as 6. So if I multiply this top equation, all of it by 2, I'm going to have matching 6's. Okay, so I'm going to do that now. Multiply that top one. Remember, it's the whole equation. So -7 times 2 is -14. All right, 3 times 2 is 6. 22 times 2 is 44. Okay, again, you don't have to label them, but now we're going to be using this equation here. All right, and then this equation here that we just made. Okay, so if I'm looking at the two equations, guys, the 6's match up now. Okay, I've got a -6 in equation A. I've got a +6 in equation B. So if we just add them together, okay, they're going to cancel each other out. So I'm going to add these two equations. Okay, so 3 plus negative 14 is going to be negative 11. X, the y's will cancel each other out. And then we've got 44, take 11, or negative 11 plus 44, however way you want to look at it is fine. Okay, I'm going to solve for x here. X will equal negative 3. So guys, you shouldn't, I think with any of these, you probably won't need to use your calculator. Okay, you should be fine without it. Okay, so now we've got x equals negative 3. We're going to sub that into one of our equations. When you're subbing it in, remember to sub it into one of your original two. Okay, I might sub it in to the first one. Okay, so I've got negative 7 times negative 3. I don't know why I'm writing them all out this time, but 3y equals 22. All right, so negative 7 and negative 3 is 21, plus 3y equals 22. Okay, so take the 21, take the 21. All right, so I've got 3y equals 1. Okay, so y is going to equal 1/3. All right, so that's the answers, negative 3 and 1/3. All right, we'll get on to one of the worded problems which you'll be dealing with. All right, I might do question 6. Okay, so when you got a worded question, guys, you've got to try and create two equations. Okay, simultaneous equations, we're always dealing with two equations. Okay, just try and create two equations. So we've got the cost of apples and bananas. Okay, so we've got the cost of one apple, the cost of one banana at a school canteen is $1. Okay, so I can write that out. One apple plus one banana equals $1. Okay, it doesn't matter if you're using X's and Y's, A's and B's. That's fine. We're using apples and bananas. Okay. $1. The cost of 3 apples and 2 bananas equals $2.40. So this is a different equation. Okay, what it wants us to do is find the single cost of a banana. Okay, so again, we've got our two equations, guys. Once you get to this stage, once you've written out your two equations that look right, then you'll be fine. Okay, we can see that our two equations, the coefficients don't match up. What I'm going to do is I'm going to times the top one by 2, okay, so that our b's will match up. Okay, so I'm going to have 2a plus 2b equals 2. All right, so this is going to be, but you don't have to this B and A thing. You can do if you want, like on the video, he labels them, 1, 2, and 2A or 1A. That's fine. All right, now what we're going to do is we're going to eliminate the B's. Okay, if you wanted to find the cost of the bananas, you could eliminate the A's and find the cost of the bananas straight away. But this will find the cost of the apples first, and I'll just resub it back in. So to eliminate these B's, we're going to subtract. Okay, so now we'll just do it down the vertical. Okay, so 3 take 2 is going to be 1 apple. The 2 take the 2 is 0. All right, and the 240 take the 2 is 40 cents. Okay, so the apples cost 40 cents. What I'm going to do is sub that into the first equation, okay, to find the value of the bananas. Okay, so instead of the A, I've got the 40 cents plus B equals $1. Okay, so our bananas are going to cost 60 cents. Bananas equals 60. Include the dollar sign. Okay, so that's the value of our bananas. All right, so hopefully those examples helped. If you want to add it into your summary journals, do that. But that's what you'll be working on this week, guys.